Okay, so in this problem, I'm given that a rocket at t equals 0 is moving 150 meters per second to the right. And at t equals 8, it's moving at 214 meters per second. And the question that's given is, how far did this rocket move between t equals 2 and t equals 8? So I'm given a velocity change over time, and I'm being asked to find a displacement change over that time. So what pops into my mind is I'm probably going to want to do some kind of integration for this. So I'll write down the differential relation that I know for position and velocity, since those are the two givens. So dx dt is equal to v. So what I'm going to want to do here is integrate with respect to time, since we have an interval of time. So that's going to be an integral from t equals 2 to t equals 8 of dx dt. We're integrating with respect to t. This will be equal to integral from 2 to 8, velocity with respect to time. Now, what this is going to give me is it's going to give me the displacement from t equals 2 to t equals 8. I'm going to write this up here. So I'll just call this delta x, and we know this is going to be the displacement from 2 to 8. And now v. What is v? So from your kinematic equation relations that you know from class, it's going to be v naught plus a times t. So we're given v naught, but we need to know what is a. So we can find a pretty easily because we're given a change in velocity, and we're also given the time period that that change in velocity occurs. So we can pretty easily see that the change in velocity here is 64 meters per second, and the change in time is 8 meters per second. So 64 divided by 8, that's going to give us 8 meters per second squared, so our acceleration is 8 meters per second squared. So I can rewrite this as 2 to 8. Now what is v naught? V naught is 150 meters per second. So 150 plus, we know our acceleration is 8 meters per second squared, so 8. And then we are integrating with respect to t. dt. So now let's do this integration. This is delta x. So this will be 150 t, 2 to 8. So it would be 1/2 8t squared and 2 to 8. Okay? Now all I have to do is evaluate t at these limits. So this will be 8 minus 2, so that'll be 6, so this is 150 times 6, plus this will be 4, and this will be 8 squared minus 2 squared, so that's 64 minus 4, which is 60, so this will be 4 times 60. Okay, so 150 times 6, what is that? That's 600 plus 300, so that's 900. What is 4 times 60? Well, that's 240. So we add those together, we'll get that our delta x from t equals 2 to t equals 8 is going to be 1140 meters.